200 years ago, which is the blink of an eye in human history, not a single person on Earth knew why or how we came to exist. Many Enlightenment thinkers would have given an arm to have that knowledge, but they were just born too early to ever know. Now, not only do scientists have this privileged information, the general public does too. Practically every educated person in the modern era is familiar with the concept of evolution, even if many misunderstand it or choose not to believe in it. In fact, knowledge about natural selection has become so common that many people find learning about how we came to exist as downright boring. This is in part because of the way that evolution is taught in most schools. It's labeled as a theory and stripped down to only a few basic components, without broader context about its implications. I'm here to make the case that not only is learning about evolution fascinating, it's surprisingly useful as well. But before we dive in, how confident can we actually be that evolution is the origin of life on Earth? Well, barring a divine conspiracy where an all-powerful being made it really look like we are the product of evolution to test our faith in them, there's probably less than a 1 in a million chance that we didn't evolve via natural selection, for two major reasons. Number one, the evidence for evolution is absolutely overwhelming. By examining the fossil record, scientists have documented a remarkably precise picture of the progression of natural selection over millions of years. Each geological period has its own set of species, whereas adjacent periods have distinct but closely related species, which fit together almost perfectly like a puzzle. It looks exactly like what we'd expect to see if life evolved slowly over the ages. This is just one category of the mountains of evidence, though. Everything we've learned about biology and genetics points to the same evolutionary mechanisms that created our fossil record. On top of all that, evolution has been observed in real time among viruses, bacteria, and even a certain species of snail. The second reason that we can be so confident about our evolutionary origins is that once you understand how basic but powerful evolution is, it becomes clear that it's the simplest possible explanation for the complexity that we observe in nature. It's sort of like this. Let's say a friend of yours comes over to your house, and while your back is turned to them, one of your lamps falls to the floor and breaks. You ask them what happened, and they say invisible leprechauns came out of nowhere and threw your lamp on the ground. As much as you'd like to believe that your friend didn't break your lamp, it's much more likely that they're just a bad liar. This presents the same problem that trying to explain away evolution has. The more wild assumptions you have to make, the less likely it is that a given explanation is true. The process of evolution doesn't require wild assumptions because we can see its fingerprints everywhere, observe its effects in real time, and apply it to everything, from selective breeding to computer simulations. Now that we've established some credibility for evolution, let's make sure we understand the basics of how it actually works. The way I'm going to explain it will probably be different than what you've heard before, but I think it's a more useful framing for understanding what's going on at a broad level. There are three core components that underlie every evolutionary process: differentiation, selection, and amplification. Differentiation just means trying new things. In natural selection specifically, differentiation occurs through the accidental mutation of genes. Usually genetic mutations don't do much at all, and they cause harm more often than good. But occasionally, they help an organism survive and get passed on to the next generation. Selection means picking the best options from a pool of candidates and discarding the rest. For natural selection, this is straightforward. Only some organisms get to pass on their genes. Whether you're infertile, fail to find a mate, or simply die young, it all means the same thing to the selection process: an evolutionary dead end. Finally, amplification means that the best options found by the selection mechanism proliferate. In nature, the most successful organisms, or the genes that produce the most offspring, get multiplied through reproduction. But here's the thing. In spite of its simplicity, evolution has produced incredibly complex biological structures made up of trillions of cells, including you and me. Even though evolution is functionally just an extremely long process of trial and error, it has the remarkable ability to innovate and retain progress. This is why we can forgive William Paley, an 18th century philosopher who argued that all the complexity found in nature was evidence of a divine creator. He was absolutely right that organisms look like they were specifically designed. But what he didn't know was that a simple 3-step process, given hundreds of millions of years, can create everything from algae to the human brain without any planning or foresight. Alright, so we finally laid out all the groundwork. We can be confident that evolution is the driving force behind life on Earth, and we understand the basics of how it works. So, what's the point in trying to learn more about evolution? To answer that, we have to make an important distinction. Natural selection is not the same thing as evolution. To be clear, it is a form of evolution, but the evolutionary process is lurking behind much more than just biology. For example, you probably have a smartphone within 10 feet of you, and if you don't, you almost certainly own one. Where did that incredible piece of technology come from? Well, it couldn't be evolution because it was specifically designed. But did the designer start from scratch, arranging all the components together from scraps of metal, plastic, and glass? Obviously not. In fact, the same three-step evolutionary process that drives biology drove the innovations leading to your phone. Differentiation happened when engineers at competing companies designed new models that they hoped would appeal to consumers. Selection happened when people purchased the phones that they thought had the best designs, allowing a select few companies to make huge profits. And amplification happened when those companies used their profits to expand production of their best-selling phones. Companies like Apple, Google, and Samsung also used the money that they made to fund R&D and develop new models, bringing us right back to the differentiation stage. As we can see, technology, like biology, has progressed due to an evolutionary process. And this is just the tip of the iceberg. Practically everything around us is the product of some form of evolution, from the clothes you're presumably wearing to the winners of the World Cup. We are incredibly lucky to be one of the first generations to understand our origins, and the more we understand about evolution, the more the world around us, and what it means to be human, falls into place. Thanks a lot for watching. If you liked the video, please like and subscribe, and I'll see you on the next one.